Maths with Fateh, and today we'll be solving surds. We'll be looking at the basic form of surds and how to solve them. So let's begin our lesson today, and let's see. Uh, for the first question, what we have at our hand is they're asking you to simplify the following surds. Okay, how do I simplify surds? Is a simple process. I simply take whatever's under the surd and I start to uh, prime factorize it. So what I get here is 2 times 3 times 3. Alright, whatever the pair is has to be outside the surd and the single digits have to be inside. So that is what I get for root 18. Alright, for the next one, they're asking us to simplify root 32. And how would I do that? I would simply prime factorize root 32 the way I did uh, root 18, and I'm just going to prime factorize it using a 2, the smallest of the prime numbers, and I get 16 divided again by 2, I get 8. 2 times 4 is 8 and 2 times 2 is a 4 and 2 times 1. So I get 2 multiplied itself by 5. So I'm just going to form pairs again. Okay. So I get 2 times 2 is a 4, and 4 would have to be the one outside the root and then 2 inside of it. So that is what I get for root 32. Alright. In the same way, I'm going to solve root 50, and the same way I would have to prime factorize using the prime numbers. So 2 is the smallest prime number that divides 50, and that is 25. Then I use a 5 times 5, and then 5 times 1. Remember, the pair always has to be placed outside the root, and then inside goes the number which is left. And then 150 would we follow the same routine, and 2 times 75 is 150, and then 5 times 1 and 5 times 5, and then I'd use a 3, so 3 times 5 again, and then 5 itself. So I have a pair of 5. So this much that I'm sure is 5 is going to be outside the root because it occurred in a pair, and 6 goes inside. So the numbers which were left over as single pairs were multiplied to get whatever is inside the root, which is 6. Alright, in the same way, I'm being asked to simplify or simplify both of these surds. So root 48 in the same way I see comes to 4 root 3 and then plus 12, which is 12 should be is 2 root 3. Okay, the way I got 48 to be 4 root 3 is I just prime factorized. I'm not going to repeat that process because that was shown in the earlier question. And then 2 times 6 and then 2 times 3 and 3 times 1. So these pairs multiplied together got you a 4, and then 3 was the lone digit which stayed under the root. Okay, the general rule is whenever we have a pair, alright, whenever we have under the root we have the same surd, we just, and there's a plus sign in between, we can just simply add these digits. So I'm just going to, for the answer for this, I'm going to get 6 root 3. Alright, because the value under the surd was the same, the value under the root was same. So let's look at the root 8 being added to root 50. I know that root 8 is going to become a 2 root 2 plus 50 would become 5 root 2. Alright, the primary concept that I'm trying to emphasize here is that whatever, if under the root the value is the same, the external digits would have just to be, you just need to add them up. So it's a 7 root 2, and that's done. And then the same thing would happen for a subtraction sign in between. So root 75 turns into a 5 root 3. Subtract root 12 change to 2 root 3. And since the values under the root are the same, so I'm just going to get the 3 root 3 as my answer. Alright, so that is it for today's video, and I hope it cleared a bit of your concept about simplifying surds, and thank you for watching.